Welcome to the LRC, where you can learn your lesson 15 minutes before the test. Hopefully. Today's lesson is algebra. By the end of the session, we hope you're able to understand some basic algebraic concepts and be able to solve a few examples. Let's get started. Let's say somewhere out there is a guy named Bob. Bob loves helping people. Every Christmas, he donates 2 times the money he earns in a month. How much does he donate? You don't know. We don't know how much he earns in a month, so your final answer would just be Bob donates twice his monthly income. Simple enough. Let's say, though, Bob forgot to donate last year. He feels really bad about it, so this time he's donating 4 times his usual donation, plus 800. This can be read as monthly income times 2 times 4 plus 800. That's a pain to write, though, and a little confusing as well. So let's just represent monthly income with M. This is better, but it's still a little longer than it needs to be. Let's instead say 2M times 4 plus 800. At this point, you may be wondering, what's 2M and what's with the parentheses? Both of those are there to represent groups. 2M means that there are 2 groups of M, and 2M parenthesis 4 means that there are 2M groups of 4. This probably sounds a little bit confusing, but if you think about it a bit more, it's just multiplication phrased a little differently. 2 times 4, for example, can be seen in a couple of ways. There's the simple 2 times 4, but it can also be represented as 4 plus 4. Alternatively, you can look at it as 2 groups of 4, because if you have 2 groups of 4, then how much do you have in total? You have 8. So, how then are you supposed to know how much you have with 2M groups of 4 when you don't even know what M is? I mean, actually, you can just ignore it for now. 2M, right? That's saying 2 groups of M, or in other words, 2 times M. 2 times 4 is the same as 4 times 2, right? In the same way, 2 times M times 4 is the same as 2 times 4 times M. So we just multiply 2 and 4 together first, and then tack on the M at the end. With that, we get 8 times M, or 8M, plus 800. Congratulations! You just learned the very basics of algebra. Let's go a little bit deeper. Here's our expression from earlier, 8M plus 800. 8's our numerical coefficient, M is our variable, and 800 is our constant. What do those mean? Let's start with variables. Usually our variable is x, but this time it's m. It doesn't really matter either way, because the only thing we need to know about our variables is that it's a placeholder for some random number that we don't have. Maybe that's because the number wasn't given, or maybe it's because the variable represents multiple numbers. Either way, we don't know it, so you write a variable and figure it out later. We can do that with the help of the other parts of our expression, like the constant. In this example, regardless of whether m is 1, 5, 10, 10k, or 0, we know that we add 800. They're pretty simple like that. The numerical coefficient is similar. No matter how big or small m is, we know that there are 8 groups of m. The coefficient is essentially just something you multiply to your variable. Does it sound complicated? Here's an example of algebra that you've definitely seen before. Here we have a basic bar model. You have 3 unknowns all equal to each other, which when combined make 90. Algebraically, this is just 3x equals 90. So, how do you solve it? Ignoring the algebra, you just divide 90 by 3, right? There's nothing wrong with this solution, but to learn the more interesting parts of algebra, you first need to fully understand what we call algebraic manipulation. With algebraic manipulation, our solution gets a little bit longer, but fundamentally it stays the same. Let's say in this situation, x is equal to the answer. We know that 3 of x is equal to 90. Divide 3 from both the answer and 90, and you'll see that x is equal to 30. Notice that we have to divide both 3x and 90 by 3. There are 2 halves to an equation, the side to the left of the equal symbol and the side to the right. Whenever you do something to one side, you have to do the same to the other, or else it wouldn't mean the same thing anymore. If you only divided 90 by 3, your final answer would be 3x is equal to 30, which we know is wrong, because 3x is equal to 90. When you look at these expressions and equations, you may think that variables are kind of bums, which, they are. You don't really know what they are yet, so until you do, you just ignore them. Let's talk a bit more about how you actually find them then. Here's an equation. X plus 15 minus 8 equals 35. How do you find x? You can do that by looking at everything around x. We know generally what x is because we know what it is when you add 15 and subtract 8. When you do that, we know that it's equal to 35. 15 minus 8 is 7, so we can just simplify this to be x plus 7 equals 35, and it'll mean the same thing. What do you do now? In our previous example, if you noticed, to get our final answer, we needed x to be the last thing in its half of the equation. That happened because we found a way to get rid of the coefficient. We can do the same with our constant. We need to get rid of the 7 to know what x is, and we do that by just subtracting 7. We have to subtract 7 from 35 too, so again, our statement stays consistent, because if x plus 7 is 35, then x on its own can't also be 35. Now, we know that x is equal to 28. Simple enough, right? Let's look at one last example. 2x plus 4 equals 3x. How do you find x when it's on both sides of the equation? It's actually pretty simple. You just get rid of the x on one side of the equation. 2 groups of x minus 2 groups of x is obviously 0, but what's 3 groups of x minus 2 groups of x? It's just one group of x, or in other words, it's just x. If this confuses you, let's consider it with some real numbers. Let's say that x is equal to 7. We have 2 groups of 7 minus 2 groups of 7, and 3 groups of 7 minus 2 groups of 7. 2 groups of 7 is 14, while 3 groups make 21. So we're looking at 14 minus 14, and 21 minus 21. From that, we would get 0 and 7, or 0 and x. That's great and all, but remember our first problem? 8x plus 800? How do you solve for x there? Well, you can't. We don't know what number we get by adding 8x to 800, so there's no way to find what x is on its own. This is an example of an algebraic expression. Basically, while an equation has two sides separated by an equal symbol, expressions don't have an equal symbol. Here's a quick summary. Basically, algebra is doing math even when you don't know all the numbers. It's not a complete reinvention of math, it's just rephrasing and getting into the very specific details of things. Algebra's main difference are that we have variables. We don't know what variables are, but we do know that they're there. If you have an equation with an equal symbol, you have two groups that mean the same thing. So you can compare them, and you can figure out the variable from that. If you just have an expression, though, you don't have another group to compare to, so you can't. That's one example of algebra having a lot of grouping and multiplication, typically represented with parentheses. Okay, we discussed a lot today, but if you want to remember any of it, then you'll have to practice. Here are a few sample problems for you to try out. The answers will be in the description. If this helped you out at all, then consider sticking around for future videos. We'll go a bit deeper into algebra, but soon enough we'll start discussing math as well. Until then, we'll see you around.